Next, let's move into adding and subtracting rational expressions with unlike denominators. This time our denominators are not going to be the same, so we need to find a least common denominator for the rational expressions in order to be able to add or subtract them. Here in our first example, we have two rational expressions that we're trying to add together, and we notice they have different denominators. So the first step is to factor those denominators. Let's take the first one, x squared plus x minus 12. We need to find two numbers that multiply to be negative 12 and add to be 1. So 1 times negative 12 is how we get the negative 12. And b being 1 here with the x is what we need to add to. And we can write down factors of negative 12. Negative 1 and 12, if we add we get 11. Negative 2 and 6, if we add those we get 4. Negative 3 and 4, we add those we get 1. So we want to split this x into negative 3x plus 4x. And we'll copy down the x squared and the minus 12. Once you break that apart, you can either factor by grouping or factor using the box or the area method, whichever you're comfortable with. I'm comfortable with factoring by grouping, so I will do it that way. In the first pair, x is in common. X minus 3 will be my reverse distributive property. Bring that plus sign down. 4x minus 12 has a 4 in common. And then 3 times 4 would give us negative 12. So the x minus 3's become our next greatest common factor. And we write the leftover bits x plus 4. That we're going to put right here underneath the 3. 3 divided by x minus 3 times x plus 4. Working on the other rational expressions denominator, x squared minus x minus 6. A is 1, c is negative 6. We need two numbers that multiply to be negative 6 and add to be negative 1 this time. And negative 6 we have 2 times negative 3, which would give us negative 1. So we want to split this x into 2x minus 3x. So x squared minus plus 2x minus 3x minus 6. We can group the first two, group the last two. X is in common with the first group. Minus sign will come through. 3 is in common in the second. X plus 2. And we have x plus 2 times x minus 3. And that will go in our second denominator, x plus 2, x minus 3. Now, the next step, once we have our denominators factored, we need to come up with a least common denominator. When I'm doing a least common denominator, I take everything in the first denominator and I write it down. X minus 3, x plus 4. Those must be in my least common denominator. I have to have those factors there. In the second fraction, I compare the factors of the second fraction with what I have listed in the LCD. Do I already have an x plus 2 over here? No, so I need to include x plus 2. Do I have an x minus 3 over here already? Yes, so I do not need to write it again. I already have one, I do not need to repeat it. My least common denominator for these rational expressions would be x minus 3 times x plus 4 times x plus 2. So I take only as many copies of a factor that I need in order to be able to recover the original denominators in my problem. So notice x minus 3, x plus 4, I have that denominator here in my LCD. Similarly, x plus 2 and x minus 3, x plus 2, x minus 3 are present in my least common denominator for the second rational expression. Let's do one more together and then I'll leave the last one for you to try on your own and also provide answers. So if you are in my class, you will be able to check your answers by going to the class OneNote. Here in the example, x divided by x minus 2 minus 3 divided by 2 minus x, we take a look at our denominators and, well, really there's nothing we can factor out right away. One thing to notice that would make it easier to work this problem in the long run is if we recognize the opposites. So noticing that x minus 2 and 2 minus x are opposites. So I can rewrite 2 minus x as negative x plus 2. And then I can factor out a negative 1 in the front, x minus 2. And you can see the x minus 2 with a minus 1 being multiplied in front, just like opposites. So the first denominator will keep the same. The second denominator, we can write it as negative 1 times x minus 2. We could make the LCD negative x minus 2. But negative 1 is really an interesting number because if I have a negative 1 here, that's equal to having a negative 1 divided by 1, but that's also equal to a 1 divided by a negative 1. So even though the negative sign is occurring on the denominator of the second rational expression, I get to move that negative sign to the top if I want to, instead of having it to the bottom. So what I mean by that is we can take that negative and throw it up top with the 3, instead of leaving it down in the denominator with the x minus 2. All because of this property of our negative 1. As long as we have a positive divided by a negative or a negative divided by a positive, we can move that negative sign to either side of the fraction bar as it's convenient. So here, our LCD could just be x minus 2. That's the simplest one we could have. Having that negative sign moving up into the numerator will actually help us with the overall structure of the problem, make it a little bit easier for us to deal with. And there are 2 more examples on this particular worksheet. If you want to take a look and try them on your own, practice them. And in these examples, we're just practicing to get that least common denominator. We're not simplifying yet. That will be the next part of our video series, is actually adding and subtracting these rational expressions with unlike denominators. We'll put all these pieces together, see how they all fit, and be able to simplify these rational expressions.